Hello learners, today in this video we shall discuss DBMS important concepts, its related questions and a proper interview answer that can be given at the time of interview. Even I am going to give you a proper interview answer with proper English. See, for example, in this manner, okay? Now, we shall directly go to our first question. What is a database? What is database? See, as the name suggests, base. So there is a base where data is being stored. See, for example, take any app like YouTube. See, we watch videos on YouTube, right? So the videos which we watch on YouTube are not stored actually in our mobile or computer, but still we are able to watch it because they are stored somewhere in a database. Similarly, we shall take example of Amazon. So Amazon in its database will store various data such as user data like user's name, user's phone number, user's PIN code, user's address, user's email address, etc. And there are various new products or products listed on Amazon which are stored in the database like pen, pencil, laptop, phone, etc. Third is even income data like how much profits are Amazon getting, what is the net income, etc. So all the data is being stored in some kind of database that can be easily accessed. So database is simply a place where data is being efficiently stored. That's it. Okay. A database is an organized collection of data that is stored, managed and accessed electronically. It allows users to efficiently store, retrieve and manipulate data in a structured format using a database management system, that is DBMS. Okay. Now I think we can go for our next question. DBMS. So this is our actual subject, right? DBMS. DBMS simply means database management system. See, we studied what is a database. See, what is management system? When something is getting managed. What is getting managed here? Database. See, again we shall take same example of Amazon. See, assume that Amazon has this kind of database with users, products, income. So, tomorrow, willing a new user come and sign up? Yes, new users can come. Similarly, cannot a new product come? Like, assume Samsung S25 might come or any S30 or such kind of new products might come. So, Amazon should be able to add them. Similarly, every day Amazon's profits, incomes also will be altered, right? So, here data insertion, data updation, even sometimes data deletion should be there, right? So, this is what data managing is called. So, not only storing data in some kind of base, but also the data have to be managed. That is simply called as database. Now, we shall see a proper definition. Hey, what is database management system? So, database management system is a software for storing and retrieving users' data from database while considering appropriate security measures. Okay. Now, we shall go for the next question. What is SQL? See, basically SQL means structured query language. See, we shall come from last. Language. Everyone knows what is language? Something that is used to communicate or talk with others like English, those all. Okay. Now, query. What is query? Query means some kind of storage or some kind of data. Okay, now third is structured. So this is been structured. See, basically what is SQL means? It is a kind of database manipulation language. So here we studied DBMS. So SQL is a DBMS language. Okay, now see, everyone may ask, why actually this SQL is required? Okay, see, now I will show you two examples. First example, I gave you some kind of information in paragraph. The student information is as follows. Rule number 1 corresponds to John, who is 20 years old. So boring and long information. Instead, I gave you information in format table. Very simple and easy to visualize. Student number 1, John, age 20. Okay. It's a very simple data. So this kind of structured data that is being stored in tables with fixed rows and columns is known as structured query language. And in this manner, SQL stores data in the database. Simple? Okay, now we shall go for the answer. Hey, what is SQL? So SQL means structured query language. It is a standardized programming language used to manage and manipulate databases. It allows us to perform tasks such as querying data, inserting records, updating data, and deleting entries. SQL is used in most relational database management systems, sir. Okay, so this is the answer. Everyone might get a doubt. Hey, up until here it is okay. What is this relational database management system? Because we studied that a database management system is SQL. From where this relational came? Now that is going to be our next question. Once check this answer, then we shall go for our next question. Okay? Right. Yes. What is RDBMS? Relational Database Management System, and how does it differ from DBMS? Okay, now basically I again here are three given tables. Okay, see, first we know that this table exists with student ID, first name and age. Now look, I am seeing something. This table and this enrollment table, these two tables are connected, right? See, suppose I want which courses did this particular John take. So what will I do? Hey, where is John? Yes, John. What is his student ID? 1. So now I will go to my enrollment table. I'll see. Hey, this John rule number is 1. What are his course IDs? 101, 102. Superb. But now I am asking you, what are the course names? See, we are developing a relation between these three tables. Now again, John took course 101, 102. Check. For 101, what is course mathematics? For 102, what is course history? It is simple. So just with these small three tables, we can calculate much huge data. See, if you try to represent these three tables in some kind of paragraph, it is going to take a very big pages. Instead, if you even try to club these three tables, it will take a very huge table. Instead, if we divide into three tables and call it a relational database management systems, see how easy it is. I can calculate anything from this literally. I can calculate even who took computer science. I can see 103. 103 is student ID 3. Who took 3? Michael. Simple. What is his age? 19. So this is what relational database system is. All tables are connected to each other, which improves efficiency of the database. And even space is very lessly consumed. Okay, now we shall see answer. Hey, what is RDBMS? Sir, RDBMS refers to Relational Database Management System. It is a type of DBMS that stores data in a structured format using tables with rows and columns. It supports relationships, sir, between different tables, allowing for more complex queries and data management. Some examples include MySQL, PostgreSQL, and Oracle, sir. Thank you. So these are the examples. Okay. Now, I think we can go for our next question. Fifth question. What are the benefits of using a DBMS compared to traditional file-based system? Okay, see, this answer we already previously discussed why we use this SQL or DBMS. Because it is very easier to represent and visualize information in the kind of tables instead in this kind of huge paragraphs which has much duplicate terms or also termed as redundancy. See, if we represent like this, matter will be more consistent, efficient, no duplication or no redundancy, space will be saved. Now we shall see a proper interview answer. Okay, now I'll be zooming it. See, a DBMS offers several advantages over traditional file-based systems. See, first one is data integrity. It ensures that data is accurate and consistent. See, I said you the table data is so accurate and consistent. Okay. Second is security. Provides mechanisms to control access and permissions to sensitive information. See, in the previous example of Amazon, we discussed income data, right? This income data should be only accessed by Amazon, but not by each and every person. So in that manner, it maintains data security. Third one, we already discussed, no duplication should be found. That is, data redundancy will be reduced. No duplication. And fourth one is efficient data access. See, this DBMS has very good software through which we can fetch the data faster compared to normal data. And the fifth one absolutely is going to be backup and recovery. See, in case of any system problem, if we store data in some kind of cloud or database, it is very easily to retrieve it. Okay. No. Okay. Now we shall go for our next question. Describe the different types of languages in DBMS. Look, basically there are 4 types of languages in DBMS. See, clearly we shall study each and every language. But first, we shall briefly understand what each step what happens in DBMS. See, initially, what should happen in database means we have to create a database which consists of a table and some kind of attributes or columns with, for example, Amazon consists of user data, product data, income data. Okay, the first step is creation. Something should be created. Okay, second thing, okay, creation is completed. Now, if Amazon created this kind of database, so tomorrow cannot a new user come and add to Amazon database? Absolutely. A new user can come and add anytime. So that's why this database should be able to manipulate or it should be able to edit. Okay. Third thing is security. See here, for example, income data is very precious. Okay, it is a bit of privacy for Amazon. Now, some kind of random guy Rahul cannot access Amazon profits income data. Instead, if it is Amazon admin or Amazon owner, he can access the income data. So the security also should be managed. And the fourth thing is save. After all the transactions are complete, somewhere in the form of table or in some manner, data should be stored. So these are the basic 4 types of languages. Now we shall go into proper technical names of each of them. Okay. Now, the first one is data definition language. See, as I said, you definition, that means it will create. It is used to define and manage database. Create, alter, drop. See, alter means not edit. It is a different kind of operation. Don't confuse. We shall discuss clearly in SQL. Okay. Second one is data manipulation, means it will help to edit, like select, insert, update, delete. And the third one is data control language. Who should access it? Should it grant the permission or should it not? That means revoke. And the fourth is transaction control language. Transaction control language means after all operations are being completed, after committing and rollbacking, it should save at some place or point. Okay. Yes. Now we shall go for our next question. What do acid properties mean in the context of DBMS? Please don't confuse. This is not chemistry acid. This is computer acid. Okay. It is not very dangerous. It is very useful actually, this computer acid or DBMS acid. See, basically acid properties means, actually this is some kind of shortcut. See, acid means, A means atomicity, C means consistency, I means isolation, T means durability. ACID, acid. Now we shall understand why, what is the use of these acid properties. Okay, see, first thing, what is it? Atomicity. See, we shall study what is atomicity. What it says, ensures that each transaction is either fully complete or not at all. See, don't confuse. We shall clearly understand this. See, suppose think there is a person named A. He is sending money to two different persons, B and C. See, for example, think this. He has initial 5,000 balance. He is sending 1,000 rupees to B. Now, in this sending process, two important steps should happen. First thing, if he send money from A to B, from A 1,000 rupees should cut. Okay, first thing 1,000 rupees should cut. Second thing, what should happen is, in B 1,000 rupees should add. So these two steps combinedly should happen. It should not be like from A 1,000 rupees has gone, but in B it has not credited. It will create chaos. Okay. See, either two steps should combinedly occur or none of the steps should occur. Simple thing. Okay, that is atomicity. A transaction should fully complete or it should not occur at all. Okay. Second thing is consistency. See, consistency guarantees that a transaction brings the database from one valid state to another. See, consistency means, look, okay, this guy sent it to be 1,000 rupees. That is super. This guy received 1,000. See, remember, adding 1,000 means not only adding simply, his final balance also should increase. It have to be consistent. If a transaction has been occurred, all related changes should also occur. If money has been added to account A, his overall balance should increase. Similarly, overall balance of A should also decrease by 1,000. See, he also sent some money to C, so it also decreased to 500. It became 3,500. That means database is consistent. Okay. Now, the third letter I, isolation. See, I think by the name only everyone understood. Ensures that the transaction of one is isolated from others to prevent concurrent operations from interfering. See, look, dude. A is sending money to B. Super. A is also sending money to C. These two transactions should not know each other. See, if A is sending money to B, this guy should receive 1,000, finish. And this C should similarly receive 500. It should not happen something like from this 1,000 half money should go for this C, from C half money should go for B. No. these two transactions are completely separate, even though they are coming from a common parent or host, but the two transactions should not know regarding each other in order to resist any chaos. Okay, simple. And the fourth is durability. See, durability means nothing, dude. It checks that the transaction history is maintained and it is permanent. Generally, if we do any UPI payment, if it is successful, we'll be getting some kind of bank balance message, right? That ensures that our transaction is being saved and it is reflected in our bank account. So these asset properties are the most important in computer DBMS. Is it okay? Now, I think we can go for our next question. Explain different types of keys in DBMS. Okay, see, keys. In general life, what are keys? Keys are generally used to, I think it's like a bullet, sorry, adjust. I think keys are generally used to open some kind of door or any big thing. Similarly, in DBMS also, keys are used to open or identify individual rows or tuples from a database. Tuple means, don't confuse, they are rows only. Okay. Now, there are basically 5 types of keys. Okay. Primary key, foreign key, candidate key, composite key, super key. We shall discuss each and everything clearly. See, first thing, primary key. As the name suggests here, primary. Primary means it will come first. It uniquely identifies each record in a table and cannot contain null values. See, in this table, order ID is a primary key. See, using this primary key order ID, I can uniquely identify whole table, right? See, for example, think I want to know order number 1 or 3. Simple. These all will be coming. But I cannot say customer ID is primary key. Look, one customer can order 2 different items. If I say 1, if I say I need customer ID 1 data, so it cannot uniquely identify a single row, right? Because see, 2 rows are having same customer ID. So keep that in mind. Primary key is used to uniquely identify any tuple or row in database, and primary key is single. Here order ID is the primary key. Okay. Now we shall go for a HT foreign key. As the name suggests. See, foreign means what? Somewhere outside. So basically foreign key establishes a relationship between 2 tables by referring to the primary key of other table. See, okay dude, here customer ID is not a primary key. Agreed. But if I have a table tomorrow which is on customers, like it has customer ID, customer name, customer phone number. So in this case, customer ID can act as a primary key, right? Because each member will have only one ID. Okay. So that is why in this table, customer key is a primary key. Now, if I want to connect these 2 tables, foreign key is used to connect these 2 tables by using customer ID as a foreign key. This customer table and order table can be connected very easily. So here customer ID can be a foreign key, even product, even if it's related for a product, even product ID may be a foreign key. Okay. Cool. Now, third is okay. See, we shall go for super key. See, super key, it is something super. Any combination of attributes that can uniquely identify rows in a table. See, as I said here, see, of course, I agree that order ID is enough to uniquely identify a row in the table. But is only order ID there that can uniquely identify? No. See, yes, if you take only single, Yes, order ID taken singularly can of course act as a primary key. But why not order ID mixed with customer ID, order ID mixed with order date can also act as a kind of key, right? Of course, order ID is individually enough, but if we club that with customer ID or order date, still it will be able to uniquely fetch the rows, right? So this is called super key. Okay, it can have more than one attributes. Okay, now super key is over. Candidate key. See, a set of attributes that can uniquely identify a row in a table. One of these is chosen as the primary key. See, there is a difference between candidate key and super key. Okay, basically super key consists of order ID, customer ID, but minimal super key is known as candidate key. That is order ID. See, you may think, hey dude, here primary key and candidate key are same. What is the difference? Look, suppose if I include one more column or attribute named serial number. See, if here serial number will also act as one of the key that can uniquely identify. It can also act as primary key. So here in our case, serial number and order ID both will be candidate keys. Both can uniquely identify. But as primary key is only one, from candidate keys, if there are many, we will be choosing one of them. So here I choose order ID. Even you can choose serial number if it exists. Simple. Okay. Now, what are purposes of a view in DBMS? This is a very good question. See, view is nothing, dude. What is view? View means seeing. What we'll see? We see only what we want. Okay. In this world, there are many things. We choose to see things only which we want. Similarly, in DBMS also, there is a very huge table of user info here. But here I need only data of users above 30 age. So simply I will write some kind of SQL code or Mongo code so that it will fetch me data only of names and age of persons whose age is greater than 30. Simple. View is just a kind of subtable. Okay. Simple. It gives us only what we want. It neglects all the useless. Okay. Now, we shall see what are some advantages. First one is data abstraction. See, as you know, what is abstraction? Show only required data is being shown. Here, only age and name are required. City is not required to show that is. We are not showing city. Simple. Second thing, security, of course. As we are showing only required, security will increase. Third is simplified querying. Absolutely. Again, these three are indirectly same points. Simply, only the queries or rows which we want from the huge table can be filtered out using these views. Okay. Now, next thing. How do the having and where clauses differ? Okay. This is a simple and complicated question both. See, having and where both are actually similar. But still they are different. Same, but different. Okay. See, we shall see how. Both are used to filter table based on a given condition. See, where is very simple, dude. There is some kind of products table here. I want only electronic products. So in my code, I will write filter me only electronic products. That means whose category equal to electronics. Give me those. Simply it will be giving me the output. But so you may think, okay, that is okay. Then what having will be doing? It is also filtering similarly only. Wait, there is a small difference. Here, see, here I want category quantity. See, that means I want to group these electronics, group this furniture. That means there are two categories here. I want to group these and filter. So, having is used with group by generally. Okay, filtering by grouping is where having is used. Here there are two things: furniture, electronics. It gave me the total quantity by adding these. Simple. Okay. If we go for the classical definition, filters rows before any grouping task place in SQL query. It applies to individual rows and is used with select statement. Keep that in mind. Having similarly filters groups after the group by operation has been performed. It is typically used with filter aggregate functions. With aggregate functions, it is being used like sum, max. We shall discuss afterwards clearly what are aggregate. Okay. 11th question, what is a join in a DBMS? Again, join means it is joining something. Here in DBMS, as we deal with tables, two tables are being joined here as per our use. Basically, there are four types of joins. We shall clearly understand regarding them now. See, four types of joins are inner join, left join, right join, full outer join. What is inner join? Inner join means assume there are two tables A and B. Inner join selects only common attributes or values from the both tables. Only this common intersection part. Second is left join. Again, if A and B are two tables, it will select only attributes mainly from A table and from B table. If there is any match, then only it will select. Majorly, it will be selecting 100% from A. If from B they are not null, if they are not there, it will just mark them as null. See, again, third is right join, which is exact opposite of left join. It will include values 100% from B and also from A. If from A they are not there, it will just include as null. But 100% from B it will include. Similarly, full outer join means it will include both tables attributes as per equate. It will join both the tables independent of which attributes are there or not. If not there, it will just include null. Okay, now we shall see the clear example. See, here there are two tables, customers and the orders which they kept. See, inner join, I think I can zoom it. See, in inner join, what is happening is, see, I said in inner join, only common things are being focused. See, what are common in these two tables? First thing, customer ID is common. Now using customer ID, we shall check which values are matching. See, customer ID 1, 2, 2. See, 1, 2. That means Raju, Amit 2 times have to be surely included. See, Raju, Amit 2 times are included and absolutely the related information which we want we can fetch. Okay, completed. So, again, second thing. Result of left join. See, what is left join? It will consist values of mainly shift for sure. See, absolutely Raju. See, Amit in the second table is appearing 2 times, kada. So that's why 2 times Amit has come. Of course, Priya Sneha. As this Priya did not order any item, it will come as null. Similarly, now we shall go for right join. See, right join says that it will 100% include values or attributes from the second. With respect to second, it will add the first table. And now see, here there is laptop, smartphone, tablet, chair. Absolutely, laptop, smartphone, tablet, chair are being there here with their quantities and their customer names are being fetched from this customer's A table. Now, a result of full outer join. Full outer join means as the table suggests, it will include all the possible values. See, Raju 1 time as he ordered 1 item. Amit has ordered 2 items. See, 2. He ordered 2 items. Priya ordered 1 item. Sneha ordered 1 item. See, here you can observe Well, see, chair. Who ordered chair? Chair was ordered by a customer ID number 5. Here, there is no customer ID with 5. I think the customer is being theft or his account is being deleted. So there is no information. So simply it will be filling as null, but still the product will exist a chair and its quantity 2. Okay. Now I think, okay. Now, keys are its definition. Inner join returns records with matching values in both tables. Shift join returns all records from left table and matched records from the right table with null for non-matches. Right join, exactly opposite of left join, return all records from the right table and the matched records from the left table with null values from non-matches. Full join returns records when there is a match in either left or either right tables with null values from non-matches. Is it okay? Now I think we can go for our next question. Okay. 12th question. Explain ER model in DBMS. See, ER model means entity relationship model. See, basically in ER model, there are 3 main concepts. First is entity, second is a relationship, third is attribute. See, entity means it is just a complicated term, but in very simple words, entity is just a real world object like student, teacher, anyone. Any real world object is termed as an entity. Second, attribute. What is attribute means? Something that is connected to the entity, like student has roll number, student has a name, student has mobile number, student applies and studies various courses. So this roll number, name, mobile, course are various attributes. This entity, the real world object, is connected to various attributes. Third thing, relationship. The relationship between an entity and an attribute is known as a relationship. Simple, 3 main concepts. So see this diagram. In this diagram, there is a student. Okay, student. He is a real world object called as entity. Here there are various attributes: roll number, name, mobile, courses which he took, etc. Okay, these are the attributes. And look at the connections. See, this line is a connection. Okay, now see here there are still many types of ER model diagrams. See, a rectangle means entity. Okay, superb, we studied. Line means it will connect attributes. We studied ellipse. See, this one only. Attributing ER diagram. Fourth is, look at this diamond. Connects attributes to entities. See, what is this diamond means? I'll be showing you a diagram. See, student, roll number. Okay, see, this has is there now here. This is the showing what kind of relation. Student, roll number. Student will have a roll number. That is what this diamond shows us. Double rectangle shows multi-valued attributes. See here, mobile number has a double quotes, a double rectangle. Anytime, generally double indicates that it is multi-valued. A student might have multiple mobile numbers. Of course, right, everyone might have 2 SIM cards with 2 numbers or any mother number, father number, etc. in that manner. Okay, this is ER model. If asked in interview, our answer would be the entity relationship model is a conceptual framework used to represent structure of a database. It consists of entities, that is objects, and a relationship between those entities, helping in visualizing and designing database schema. Okay, now we shall go for our next question. Types of relationships in DBMS. See, until now we studied in ER model ER. R means relations. Again, relations are also generally of 3 types. Okay, generally of 3 types, and even you may even derive to 4 or 5. We shall see the important 3 types. First is one-to-one relationship. See, there is an entity student, a real world object student connected to something called as rule number, which represents this particular entity. See, one student will have only one rule number. That is why it is called one-to-one relationship. Finish one-to-one relationship, clear? Now, we shall go to a second kind of relationship, one-to-many relationship. See, one student may be enrolled in multiple courses, such as he may enroll in PHP course, Python course, Java course, or still may be many like C++, Node, SQL, Mongo, etc. Right? One is connecting to many. See, similarly, there is even one more type in this, which is many to one, where many things are connected to a single one. Okay. And fourth one is many to many relationships. See, for example, there are 3 students here, and these are various clubs in the particular college or school. So one student might enroll in many clubs. And similarly, one club may have multiple students. So that is why this is many to many, or termed as M:N relationship, where M is a number of these first side entities, N is second side attributes number. Simple. If asked in interview, see, generally we will say only 3 types. If you want, you can even include that many to one. Okay. There are 3 main types of relationships in DBMS. First is one-to-one relationship, where one record in a table relates to only one in another. Second is one-to-many, where one record relates to many records in other table. And the third important is many-to-many, where many records relate to many others in other table. If you are interested, you may even add many to one here, which is just vice versa of one-to-many. Okay. Now we shall go for our next question. What is normalization and its purpose? See, normal. Here the term is enough, I think, to understand for most of people. See, it will make anything into normal. See, assume here there is a very big data set or data of 1,000 rows and 1,000 columns, which is around, I think, 10 lakhs of data, which takes much memory to store. But we are restricted only to some memory, right? Why to waste memory? That is why this normalization came into existence. What normalization does is, it splits a huge complex table into multiple smaller tables by reducing the dimensionality. And main purpose of this normalization is to decrease the redundancy. That means duplicates can be removed. Simple. Okay. See, here there is 1,000 cross 1,000. Simply be converted into 10 cross 10, 10 cross 10, 10 cross 10. Again, if you multiply these all, you are going to generate 1,000 cross 1,000 rows and columns. See how much space are you saving. Okay. This is a normalization. If see, even there are types in this normalization, we shall discuss even them in the further questions. Now, if asked in interview, normalization is a process of organizing data in a database to reduce redundancy and improve data integrity. Its purpose is to ensure that the database is efficient, consistent, and easy to maintain by dividing tables and setting up relationships in between them. See, he asked only normalization. Say answer for only normalization. If he is not satisfied, or if you want to answer, or if he asks, then we shall go to the types of normalization. Basically, normalization is of 3 types, or even in some cases 4. 1NF, 2NF, 3NF, BCNF. 4th type is, it is an advanced concept, BCNF. We shall even study that. Okay, first we shall go for explain 1NF in DBMS. See, remember the core concept of normalization. Normalization just converts a very complex high dimensionality table into a simple less dimensionality table. See, according to 1NF, there are some rules. Each cell must contain a single value that is termed as atomicity. Okay, the first and second is each record needs to be unique. To only tense we shall understand with respect to our example. See, there is any random given table, dude. It is a student skill table with student ID, student name and the skills which he have got. See, here he said each cell must contain a single value, that is atomicity. Here look, there are two or three skills clubbed in just one cell, which makes searching so hard. This may look very simple, but when you write the code for searching, it is going to take an exceptional time level complexity. So, our 1NF makes this complex table normal. What will it do? Simple. It should contain only single value each cell. No, that is why it will divide the skills. Like, see here, one cell only consists of one value. See, again, these two tables are same. See, John Smith have Java C++. Yes, John Smith have Java, John Smith also have C++. Simple. This is what 1NF is. Now, we shall go for our interview answer if specially 1NF is asked. 1NF states that a domain of an attribute should contain only atomic values, which means that a column can contain only a single value per row. That means each cell should contain only one value. See, domain means just the values which we put. Domain means it is just the column name or attribute. Okay, simple. Check the answer. Okay, I think we can go for a situation. Absolutely. Explain 2NF. 1NF completed. 2NF. See, it is like if 1NF is simple version, 2NF is pro version. Remember one thing, this pro version 100% consists all the features of the simple version. Similarly, even 2NF consists all the features of 1NF. But pro, that is 2NF, consists some extra feature, that is remove any partial dependency. It is a simple term, but don't confuse. Partial dependency means we shall understand, as the term suggests, partial means something is not happening fully but only partially. See, look at this table: student ID, course ID, student name, course name, instructor name. Look here, if I ask you what is primary key, everyone will be saying student ID. No, student ID cannot be a primary key because see, the student ID, student name are connected. Course ID, course name, instructor are connected. No, that is why here partial dependency exists. See, suppose if I take, see, here primary key will be combined student ID and course ID. Now, if I say student name, it depends only on one attribute of primary key. See, partial. This student name depends only on one attribute called as student ID, but not on the whole primary key. That is why this partial dependency have to be removed. So we shall first understand the table. Student ID depends on student name. Course ID will give rise to course name and instructor name. So we shall just make two tables and make this complex table into normal splitting. Remember our first diagram? Similarly, see, I made a student table, another one course table. Student name depends on student ID. The course name, instructor and course names depends on course ID. Okay, superb. If asked in interview, second normal form to NF is achieved when a table is in first normal form and aims to eliminate all partial dependencies. Partial means, see, simple dude, partial means it should not depend only on one but on whole key. If it depends only on one of the attribute of primary key, finish. You have to divide it. Okay. Now, this is Promax. Explain 3NF in DBMS. Of course, Promax has each and every function of Pro. So, it will be in 2NF. The extra feature in Promax, that is 3NF, is eliminate any transitive dependency. I think in school, most of you studied what is transitive. Transitive means generally, if A depends on B, B depends on C. Indirectly, A depends on C. Right? A depends on B, B depends on C. So this is what transitive mean. A to B, B to C. He says in 3NF that you have to eliminate any transitive dependency. For that, you can even split the tables in how many you want. See, here what transitive dependency exists, we shall see. Okay, see, first thing here, student ID and course ID can be a complete primary key. Actually, this table is not even in 2NF. Remember, last time we divided this table. First thing, bring it into 2NF. That is, separate student ID, course ID. Second thing, see, I separated student ID, student table, course table. But here the problem is, see, we shall see how transitive dependency exists. Here, instructor office depends on instructor. Instructor depends on course ID. See, A, B, C. So we have to remove this ABC transitive relationship. That is why this course table is again been broken into this table with instructor office. Now see, no transitive dependency exists. Now everyone might get out, what is this enrollment table? See, this is the table that will help us to club any of these 4 tables or these 3 tables. See, student ID, course ID. From here, you can club these 2 tables. Again, look, instructor. Again, even you can club this 3rd table. Means all the 3 tables can be internally combined using this 4th enrollment table. Simple. Okay, finish. If asked in interview, third normalization is achieved when a table satisfies 1NF, 2NF and aims to eliminate all transitive dependencies. Is it okay? No. See, this is Ultra Pro Max. See, I want to give you one. I want to say you one thing. See, until now, which 17 questions we discussed, these are actually the most important questions. Okay. The questions which we discuss from now, you need not deep dive much into it. Of course, we cannot say they are not asked or they are not important. But the thing is that it is not required to deep dive into it until we are concerned about the interview. Okay. Now, explain BCNF in DBMS. Of course, Ultra Pro Max, it should satisfy 3NF. Second is the new, for every functional dependency, A must be a super key. Simple, dude. Simple. Here, table without BCNF. Student ID, course ID, instructor. Okay. See, here student ID is there, course ID is there. Then course ID independently or uniquely identify a row in a table? No, it is impossible because student ID, course ID both can do, but only course ID cannot do. That is why again we shall divide into 2 tables. Student ID is student table that consists of student ID, course instructor table that consists of course ID. Simple. Even you can use joins to mix these. Have an interview answer. BCNF is Boise code normal form. It is an advanced version of 3NF. A table in BCNF satisfies if it is in 3NF, and for every functional dependency from A to B, A is a super key. Simple? Simple? No. We shall go for our next question. Define trigger in DBMS. See, in general life, what is trigger? If anyone says any words for us or any words which we don't like, we instantly say, I got triggered. That means unnaturally my emotions got altered. Means something is by default happening. Something is internally happening by default. Here is also what that happens in DBMS. See, trigger means, for example, I am ordering some item at Amazon. Think, for example, okay. For example, I am ordering some kind of Samsung phone. Okay, Samsung S24 phone I'm ordering. Now, if I order 5 phones of Samsung S24 so that I can gift for my friends. Now, if there are total 100 pieces, of course, I am going to get 5 pieces. That is, of course, going to happen. But second task that should also happen is, from this total stock of 100, 5 should be subtracted and 95 should be now the current total stock, not 100. See, when this particular ordering action is being completed, at the side, at the back end, internally, this stock decreasing function or stock decreasing thing should also happen by default internally. That is what trigger does. Okay. A trigger is a set of actions automatically executed in response to certain events on a table, such as insert, update, or delete. It helps to maintain data integrity and enforce business rules within the database. Simple. One action automatically happens. Okay. See, explain stored procedures in DBMS. See, don't get feared. What is the stored procedure? This is just a cheap copy or just a copy of function. I think most of you know function. Function is 90% like a function itself, dude. Don't confuse. Simple. What is a function? A function is a block of code that can be executed whenever and whichever time we need. Similarly, that is what a stored procedure is. Okay, see, if you take an example, if I am ordering, again take the same example, I am ordering S24 5 pieces, super, these 5 pieces decrease in the total stock, super. This is what trigger does. What stored procedure does is, see, when I order this item, I will of course give the input of ordering item, quantity of item, delivery date, but there is one thing which I won't give as input but is automatically generated, that is order ID. Did you ever give order ID? Did you ever ordered order ID? No, right? It is by default. It is internally generated. We cannot say by default, but it is internally generated. That means a function is being written that will generate this order ID. Instantly we place any order. Okay. Now we will see the classical interview definition. A stored procedure is a precompiled group of SQL statements that can be executed as single unit. It helps improve performance and simplifies repetitive tasks, as it can be reused multiple times with different parameters. Simple, just like a function. Maximum like a function. Of course, it is not completely same. There are some minute differences which you can study, but it is maximum same. Okay. What is... Oh, right. Okay. I thought it was a movie name. What is RAID technology? Okay. What is RAID? Redundant array of independent disk. Okay. See, this is similar to kind of normalization itself. Of course, it may not be same concept, but again, as this stored procedure and function are maximum same, but not 100%. Similarly, Normalization and RIDE are also 90% same but still different. Same but different. See, what is RIDE technology means? See, suppose I have 100 hard disks in my particular computer memory. In order to boost the speed of my memory, I will club all these 100 units and create a new logical unit in order to boost my overall performance. You can compare this like some kind of context switching in operating systems. Memory will be shifted from some data will be shifted from secondary memory to primary memory. Similarly, here also. What is RAID technology? RAID means a redundant array of independent disks. It is a data storage technology that combines multiple disk drives into a single unit in order to improve the performance, data redundancy, or both. There are different levels of RAID ranging from 0 to 10, offers various combination based on our own benefits. Simple? Okay. I think this is our last question. Explain indexes with respect to DBMS. I think most of you got shocked. I heard this indexes name in Java, C++. From where these indexes came in DBMS? Yes, in DBMS also the same indexes which you study exist even here. See, I will give you an example scenario. Assume a student table, guys. Okay. Now, there are around 3 lakh students. Yeah, exact. 3 lakh students are there. Now, I want data regarding this particular 1,34,769th student. I need his biodata. He did some kind of here there thing. So that I need this guy's information. Who is this guy? So now, if I start search, if I make my code to search all these 3 lakh data items, when will I get the answer? My system also gets heated up. So that is why what we do is we use techniques. Okay, we use some techniques called as hashing, or we use data structures like B-trees. For example, we shall study what is hashing. What I do is internally in memory, I will be storing indices with respect to student data. Like 1 means Sam, 2 means Mikey, 3 means Aaron. Again, similarly 1,34,000 means Asta, 3 lakh means Shio. Now see, if I want this data of 1,34,000 members, just I can say hash of 1,34,769. In just one nanosecond or just in O of 1 time complexity, you can get this information of this Asta student immediately. Simple. Okay, it is just used to improve the memory complexity. Searching becomes exceptionally faster. Exceptionally. Okay, see this. See, where it was taking maximum of 3 lakh times, here it is completing only in 1 of 1. That is the power of indexes. Okay, now there are even some types of indexes in DBMS. We shall study them. Okay, first is ordered index. See, ordered index means a simple dude. It will sort. It will get sorted. That's it. Here we are not mentioning with respect to which it will sort, how it will sort. It will just sort. It will be in some particular order. Okay? So that we can use some kind of binary search techniques or an efficient linear search in order to find the answer very easily. Okay. Now, second is clustering index. See, clustering index means, see, every time, see, for example, I am watching some kind of YouTube video. I watched a very funny video or song 5 days back. I want to show that particular thing for my friend so that he gets flat and my aura goes up. But I am not getting the, I don't remember the name of the video. So what I can do is, I will search with respect to date, right? That means I am searching with respect to one particular attribute. So sorting the database with respect to one particular attribute, for example, date, is known as clustering index. Ordered sorting with respect to any one attribute in order to boost the speed of the memory is known as clustering index technique. Okay. Now, next, primary index. What is primary index? Means, as the name suggests, primary key is, you have to remember, it will sort based on primary key. Simple. Okay. Now, we shall come to this dense and sparse index also. First, we shall study what is secondary index. Okay, primary index means primary key sorting. Then, did we study anywhere secondary key? No. Then what is this secondary here? It is not secondary key actually. It is secondary memory. Okay. See, what happens is, if we have a huge database, see here, 3 lakh are there. Suppose assume you have 3 crore or 30 crore. Like that, we cannot apply these sorting techniques efficiently and store each one of them. That is why we even use secondary memory like SDDs, HDD, hard drives in order to store data permanently in secondary memory. If we fetch data from secondary memory in order to sort, it is termed as secondary indexing technique in DBMS. Now, we shall come back to our primary index. See, this primary index sorting can be of 2 types. One is dense indexing, sparse indexing. See, dense indexing we previously studied for each and every row in the particular table, there will be a record. Okay. So that it is very easy to search. But there is one exception in this. Assume there are for this world population around 10 billion. See, if I have to store 10 billions of data with hashing, my memory complexity will go to next level. Okay, company guys have to sell their company itself. That is why this sparse index has been introduced. What this sparse index does is, it will manage time complexity and space complexity. It will manage both from middle. See, here for each and every record, we are creating one hash key, right? Instead, what will be happening is, it will be keeping a mark like 10. Instead of generating hash key for one row, it will generate for the gap of 10. Finish. In this manner, it will be generating, so that space complexity gets decreased, and maybe somewhat time complexity get increased, but still it is okay. See, that is why, based on our advantage, we can use any of the indexing methods. If you have very huge data, sparse index is best. If we have some data, dense indexing is the best. Okay, simple. Now, we shall go for interview answer. An index in DBMS is a database object that improves the speed of data retrieval operations by creating a data structure that allows faster searches on the table. It acts like a pointer to the data and helps in quickly locating records without scanning the entire table. If you ask which data structure he will use, if you can say B trees or even hashing. Hashing is a very efficient technique that gives us answer in just in O of 1. Okay, so these are the DBMS important questions. I really appreciate the guys who came until this last question. Really, you are so great. I appreciate your patience. I'm not getting the words. If you really understand the concept of DBMS, please like, share, and subscribe. Okay. Thank you, listeners.